Okay, this is section 4.3, part 1, right triangle trigonometry. And today we're just going to show you another way to find the 6 trig values of like our sine, cosine, tangent of the different angles. We already know how to use the unit circle. Now we're going to do the same thing, but we're going to use right triangles to do that. And this is how I always remember my exact values for all of the angles. I don't think of the unit circle, I think of my special right triangles. So first of all, you've probably seen this back in geometry. Okay, let's review some basic terms. Here's an angle theta, and if I wanted to pick the hypotenuse of a right triangle, I always find my right triangle and the hypotenuse is always opposite the right triangle and it's always my longest side. So if this is an angle theta, and this is an acute angle because it's less than 90, and theta when using right triangles will always be an acute angle. This is the side adjacent to this angle. Adjacent sides always touch the angle I'm talking about. This is the side opposite this angle. Opposite sides will never touch the angle that we're talking about. So back in geometry, we are using the lengths of these three sides to form ratios that define the 6 trig functions. Okay, ratios, remember, are just fractions. So you may have heard SOHCAHTOA. I'm going to SOHCAHTOA. All right. So first of all, the SOH. SOH stands for the opposite side over hypotenuse. So when I have a right triangle, and it's either going to be a 30-60 or a 45-45, and I'm finding the sine of an angle, I find the angle that they give me, and sine would be the opposite side, whatever that is, over the hypotenuse side. Cosine, so in our little saying, CAH, stands for, the C stands for cosine, adjacent, hypotenuse. So for cosine theta, adjacent over hypotenuse. And then tangent is going to be opposite side over adjacent side. And then we've learned in a previous lesson that cosecant, secant, and cotangent are the reciprocals of sine, cosine, and tangent. So cosecant is the reciprocal of sine, so that means it's the hypotenuse over the opposite side. Secant is the hypotenuse, whoops, I typed this up wrong, hypotenuse over adjacent side. So you need to fix that on your paper if it's not already fixed. And then cotangent is adjacent over opposite. Okay, so we are going to do an example of using a special right triangle. All right, so this one says, use the triangle to find the exact values of the 6 trig functions of theta. So when I'm given an angle, here's my angle, I need to make sure I have all 3 sides. In this case, I don't, and I should have noted that there's my right angle. So if this is a 3, this is 4, we can use the Pythagorean theorem to find that missing side. Some of you may already know what that missing side is because this is a very common Pythagorean triple is what they call it. So when I solve using the Pythagorean theorem, that third side is going to be 5. This is a 3, 4, 5 triangle. All right, so I know all the sides of my triangle. And now we're going to list the 6 trig functions of this angle. So that means let's use our SOHCAHTOA. So I'm going to find sine of theta first. So if this is my angle, sine stands for opposite side over hypotenuse. So the opposite side of theta is 4, and the hypotenuse is 5. Let's do cosine theta. So I'm looking at this angle still. Cosine theta is the adjacent side. Adjacent side is always touching my angle over hypotenuse. My hypotenuse is 5. Tangent theta, TOA, tangent theta is opposite side over adjacent side. So 4 over 3. So these are the first three I always find, sine, cosine, and tangent, because once I have those, I know that the other three are reciprocal of these. So cosecant is the reciprocal of sine, so I'm just going to use the reciprocal, 5 over 4. Secant is the reciprocal of cosine, so that has to be 5 over 3. Cotangent is the reciprocal of tangent, so that's going to be 3 over 4. And I'm done with that one. Let's look at example 2. Find the exact values of sine of 45, cosine of 45, and tangent of 45. So they've already given me my 45-45 triangle. So it doesn't matter which 45-degree angle I use. All right, so I'm going to use this one right here. So the sine of 45. So sine, remember, is opposite over hypotenuse. So remember, this is our right angle right here. So if this is my angle, opposite side is 1. Hypotenuse side is the square root of 2. Now we know that we're not going to leave this a radical sign in the denominator, so I'm going to rationalize. And when I do that, I get the square root of 2 over 2. That's the sine of 45 degrees. And if you check on your unit circle, find the point for 45 degrees, sine is your y value, and it should be square root of 2 over 2. Let's do cosine of 45. I'm still using this angle. Cosine is adjacent side over hypotenuse side. So we got the same thing. When I rationalize, square root of 2 over 2. And that should be my x value on my unit circle. Tangent of 45. Tangent is opposite side over adjacent side. 1 over 1. So the tangent of 45 is 1, or on my unit circle, it's y over x. Okay, example 3. Use the equilateral triangle to find the exact values of sine 60, cosine 60, sine 30, and cosine 30. It's kind of hard to tell, but my 30-degree angle is right here. This is my 30-degree angle. So let's just go in the order that they asked me. I want to find the sine of 60 degrees. So I'm going to find my 60-degree angle. Here it is right here. All right, here's my right triangle, so this has to be my hypotenuse. So I'm going to find my 60-degree angle. Sine is opposite side, so square root of 3, over hypotenuse side, 2. So now let's find the cosine of 60 degrees. Here's my 60-degree angle. Cosine is adjacent side, which is 1, over the hypotenuse side, which is 2. And again, if you look on your unit circle, the sine of 60, sine is your y value, so your y coordinate at 60 degrees, or pi over 3, should be the square root of 3 over 2. Your x value should be 1/2. So now let's find the sine of 30 degrees. So now here's my 30-degree angle. So I'm going to move up here and find the side opposite. So the side opposite of 30 is 1. Hypotenuse, 2. So the sine of 30 is 1/2. And the cosine of 30. So cosine of 30. So here's my 30-degree angle. Cosine is adjacent over hypotenuse. So adjacent is square root of 3 over the hypotenuse, 2. So if you notice something, sine of 30 is the same thing as the cosine of 60. The sine of 60 is the same thing as the cosine of 30. All right, example 4. Oh, not example. All right, so basically you should begin to to memorize the following trig values in the first quadrant. These will be used throughout the school year. And it's just going to make your life easier if you know these. So really, you need to start learning the sine, cosine, and tangent of 0, 30, 45, 60, and 90. And I always remember them by my special right triangles. And we're going to review those special right triangles again in class, your 30, 60, and your 45, 45.